So this problem starts out the same as the last one. We need to find our component vector. So remember, we do end minus beginning. So we start at A, end at B. So it's 4 minus -3 for the x coordinate, 1 minus 7 for the y coordinate. So our component vector is 7, -6. And then for its magnitude, just Pythagorean theorem. So 7 squared plus -6 squared equals the magnitude squared. Solve this out really quick. 49 plus 36. So we get that our magnitude is the square root of 85, which is approximately 9.2 if you'd like to use it as a decimal. So that was the first part. We have our component vector and our magnitude. Again, visually, if you want to see that, component vector was over 7. 1, 2, 3, 4, 5, 6, 7, down 6. So again, it's switching it so you're thinking about it at the origin, less numbers to deal with. So now this next piece is we want to find the component vector 3/4 of the way to A to B. So visually that means we want the vector, our force isn't going to be as strong as we thought it was, it's only going to be 3/4 that length. So if you want to think about how to do that, the reason these component vectors help us so much, we already know our component vector is 7, -6. To find the vector that is 3/4 that, just multiply both pieces by 3/4. So the vector that is 3/4 that distance would be 7 times 3/4 is 5.25. And -6 times 3/4 is -4.5. So there is our component vector, 3/4 of the way there. Again, we just drew it, that means we went down. That's a -4.5. Last distance is a 5.25. Okay, next part of that said find its magnitude. So again, magnitude, Pythagorean theorem squared. So 5.25 squared plus -4.5 squared. Solve that out. And we get that magnitude squared is 47.81. Take a square root, and our new magnitude is 6.9. Now you can check that. Another way we could have found that is, remember, we had our magnitude of our original vector up top. Well, if we had 3/4 of the way, you can notice 3/4 times that original magnitude of 9.2. If you type that in your calculator, it also equals 6.9. So either way here, but since we had to find the component vector first, we had to go ahead and do that process of multiplying 3/4 times the whole one to begin with. So last piece we need here, we want to find the coordinates of P. That would be 3/4 of the way from A to B. So it's saying if we took that 3/4 vector, tossed it on, what would those coordinates of point B be? So in order to find that, use this little triangle we drew for ourselves. Helps us out. We know it's our components of our new vector, or 5.25 for x, -4.5 for y. We know A's original coordinates were -3, so just add them together. Either visually draw your triangle and add it out, or algebraically think we started with A. A is at -3. We are adding our new component vector, this piece right here, 5.25 and -4.5 to it, and then we're going to find out where does A and then end up, and that'll be our point P. So just type this x's, add those together, so -3 plus 5.25 gives us 2.25. And then add the y's together. 7 plus -4.5 equals 2.5. And that tells us that that is where point P would end up. And if you look at the picture, it makes sense. We're over just about 2.25 and 2.5. And this is where vectors can become very helpful in transformations. They represent translations. They represent slides we're using this vector to show how all of it comes together. So there's your final answer for point P. You just add the x's, add the y's.